as well. That'll add some more time in there.
Okay.
Let's do all of those.
Solving absolute values?
Yeah. It's on the bottom page.
Okay, absolute values, and we're just doing the yellow ones?
Yeah.
Absolute values are actually pretty easy. Same pattern for all of them. It's slightly more difficult when there's an inequality instead of an equality, but for equalities, it's real simple. Never change what's inside the absolute value. In other words, this means two things. All absolute value equations or inequalities always mean two things. They mean either what's inside is equal to 32 or what's inside is equal to negative 32. That's it. All are like that. And then solve two different equations. So if minus 4x is equal to 32, what's x equal to?
X would be equal to 8.
Negative 8.
Negative 8, sorry.
Or if minus 4x is equal to minus 32, what is x equal to?
That one's positive 8.
Okay, so those are the two possible values for x for number 2. Okay, let's go further. If I have 2 times 3x minus 2 equals 14, well, before you can take the step we took on the last question, you have to isolate the absolute value. In other words, you have to get the absolute value on one side all by itself. So what's my first step here?
Subtract 2, or would it be divide by 2?
Divide by 2. Subtracting 2 does not get rid of this 2. The only way I'm going to get rid of that 2 is if I divide both sides of this equation by 2. So that leaves 3x minus 2 on the left side, and it leaves 7 on the right. Now we can do what we did on the last problem. So what does this mean? What two things does this mean?
It means 3x minus 2 equals 7, or negative 3x.
No. Never change what's inside the absolute value.
Oh, okay. 3x minus 2 equals negative 7.
And that's going to apply when we get down to these inequalities also.
Okay.
Never change what's inside that absolute value sign. Can you solve each of these okay, or do we need to go through that?
Oh, I can solve them then.
Okay. Let's do the next one then. Number 8.
Just to make sure, though, it's adding 2 and then dividing that to equal x equals 3.
Okay.
Okay.
So let's look at number 8. So number 8 starts out, remember my goal is to isolate the absolute values on one side of the equation.
Yeah. Here you would add 2, right?
Right. Now what?
And then now it's y minus 5 equals 12, or y minus 5 equals negative 12.
Right. Now the reason I write it horizontally like this is because so I can then solve each of these vertically to come up with my answers.
Okay.
Okay? And that's kind of a standard. That's pretty much what most math people do, is write them horizontally like that. Okay, number 10 says check for extraneous solutions. And absolute values definitely lend themselves to extraneous solutions. In other words, whenever you have absolute values, radical signs, or logarithmic, beware of extraneous solutions. So this one starts out like that. So what does this mean?
Means x minus 1 equals 5x plus 10, or x minus 1 equals negative 5x minus 10.
Yeah, it would be the negative of that whole thing,
Right.
which translates to minus 5x minus 10.
Right.
Okay, so let's go ahead and solve this one so we can check for extraneous solutions.
What is an extraneous solution?
I'll explain in a moment as soon as we find one.
Okay.
So solve the left side.
Add 1, so that's 11. Minus 10. 4x is negative 11, so no, that doesn't sound right.
That's actually correct.
All right.
However, the easy way to do this is to bring the 5x to the left, making negative 4x, and to take the 1 to the right, making plus 11. And now divide both sides by minus 4, and I get x equals minus 11/4 for that one. Now let's do the right side. This one over here.
So.
In other words, keep your x's on the left side.
Okay.
It'll make it easier. And put your numbers on the right side.
It'd be the same, wouldn't it?
No. If I move this negative 5x to the other side of the equation, what do I have?
Negative 4x.
No. I have x plus 5x.
6x. Sorry.
Equals what?
Equals negative 9.
So x equals?
Negative 3.
Negative 3/2. 9 divided by 6 is the same as 3/2. Okay, so we've come up with two solutions, which you almost always do when you have absolute value. So let's plug them in and see if they are both truly solutions. So let's start with this one. So let's plug it in. We have minus 11/4 for x minus 1. Is that equal to 5 times minus 11/4 plus 10?
Wouldn't you
Well,
calculate to solve this?
this is 2 3/4 minus 1, so this is minus 3 3/4. Is that equal? Well, let's see. What is plus 10 minus 2 3/4? That is 7 1/4 times 5. Are those two going to be equal to one another?
No.
So this solution is not a valid solution. So now let's just make sure the other is a valid solution. When I plug in negative 3/2 for x, hold on a second. I didn't write that previous one correctly. It was 5x plus 10. So this parentheses belongs there. Let's see if it's valid here. What's on the left side of the equation by the time I simplify that?
It would be 3 1/2, 2 1/2.
And now apply the absolute value. Okay, so it's plus 2 1/2?
Yeah.
Okay? Now on the right side, I have minus 15 halves plus 10. That's minus 7.5 plus 10. That's also 2.5.
Alright.
So it worked for that. Let's go back and check the 11/4 again because I didn't do it right the first time. I need to plug in 11/4 for right here. Usually one of these is extraneous. So this is minus 3 3/4, the absolute value of which is plus 3 3/4.
How are you getting 3 3/4?
What's minus 11/4 minus 1?
What do you mean?
Well, what is minus 11/4 minus 1? What is that arithmetic? Do that arithmetic for me.
I'm not seeing how you do that arithmetic.
Okay, here's how we do it. We find a common denominator. 1 can be represented as 4/4. Now I operate on the numerators. I get minus 15. That's minus 3 3/4. But we'll leave it as 15/4. Since we're taking the absolute value of it, it's 15/4. Okay?
Okay.
Now let's see what we get on the right side. We get 50 minus 55/4 plus 10. Is that a positive or a negative number?
Negative.
So this is not true.
Okay.
So that is not a valid solution because it doesn't satisfy the original equation. That's what extraneous solutions mean, is you need to be able to satisfy the original equation
Okay.
with both values. Okay, let's do another one of those. Number 14. So we have 3 times 4w minus 1, and the absolute value minus 5 equals 10. What are the first two steps here?
Divide 3 and add 5.
Which order?
Divide 3 first.
No.
Oh no, add the 5 first.
Okay. So if we add 5 and divide by 3, we're left with this.
So the only reason I caught that is because it wouldn't work dividing by 3. How come you don't divide by 3 first?
Because you haven't isolated. You got to isolate this part of the expression. If I divide by 3 first, then I've got to divide this 5 by 3 also.
Okay.
I could divide by 3 first. It's just not the best way to solve the problem. It introduces fractions unnecessarily. Notice that if I divide by 3 first, every term by 3, now I got a bunch of fractions that I got to deal with.
Okay.
I don't want to deal with fractions if I don't have to. So if I add 5 first, so that I now have this, now when I divide by 3, I've got nothing but whole numbers.
All right.
So what does this mean?
It means 4w minus 1 equals 5, or 4w minus 1 equals negative 5.
Solve each of these.
W equals 4, and then plus 5.
No, I was jumping ahead. First we add 1 to both sides, and then we divide by 4.
Right. 6, 4. I'm sorry, I said the.
Or what?
Or add 1, so that's negative 4. 4 is, W is negative 4.
Negative 1. 4W is negative 4.
Right.
Divide both sides by 4, you get negative 1.
This is the problem, is like I have to write it down, otherwise my head mixes up all the numbers.
That's fine. The key to solving algebra problems is just doing it one step at a time. Don't do everything at once.
All right.
In other words, this part of it over here, add 1 to both sides first, and then divide by 4. Don't try to do it all in one step. Same thing over here. Add 1 to both sides. That makes minus 4 on the right, but I still have the coefficient of 4 on the left. So now I have to divide both sides by 4.
Okay.
Okay, so now let's check these two solutions. We don't really have to go back to there, because if there are extraneous solutions, it will show up when I plug it into there, right there.
Okay.
Just trust me on that. The only thing that causes extraneous solutions are the absolute value part of this equation. So there's no point in going all the way back to the more complicated equation and plugging in W into that and doing the more complicated math. I can go straight to this to check for extraneous solutions. So when I plug in, let's do the easy one first. Minus 1, what do I get?
Negative 4 minus 1 equals 15, or equals 5.
Well, negative 4 minus 1 equals minus 5, but then the absolute value of minus 5 equals 5, so that works. How about the other one?
3 halves. 4, and how do you do that again? 4 times 3 halves. Would that be 12 halves?
Yeah.
Okay, 12 halves minus 1. So that could just be rounded off to 6 then, couldn't it?
Well, and you don't even have to round it off. 12 halves is equal to 6.
Right.
It can be simplified to 6 is what you meant.
Yeah, that's what I was looking for.
Okay.
6 minus 1 is 5. That one works.
That one works also. So this one had no extraneous solutions. They both worked.
Right.
And that's all they mean. Okay. Can you excuse me for just two seconds, and I'll be right back?
Of course.
And we'll go on to 16. 1 second. Okay, sorry about that, Ryan. Still there?
Yep.
Okay, let's go to absolute values and inequalities. Just slightly more tricky. Not that much, just slightly more. So when I have an inequality sign instead of an equal sign, this means one of two things. And again, never change what's inside. So it means x plus 3 is greater than 9, or x plus 3, and this time you change not only the sign on 9, but the direction of the inequality sign.
Okay.
That's it. It's the only two rules you have to use for inequalities, or for absolute values, is how to handle them in an equation and how to handle them in an inequality. So solve both of these.
Alright, minus 3, x equals 6, or x is greater than 6, or subtract 3 again, so x equals greater than negative 12.
Okay, what's
No,
this?
I flipped the sign. I got that mixed up in my head. X is less than 12. Negative 12.
Less than negative 12. In other words, if I'm graphing this on a number line, here's plus 6, here's minus 12. This tells me that x is either less than negative 12 or greater than 6.
Okay.
Okay, number 20, or actually we have a whole other set of here that I didn't see these. Number 18. Okay, so what does this mean?
It means y minus 3 is greater than or equal to 12, or y minus 3 is less than or equal to 12.
Change both the direction of the inequality and the sign on the number. You got to change two things for that second part.
Right.
Okay, solve each of these.
We'll add 3, y equals 15, or it's greater than or equal to 15, or y is less than or equal to negative 9.
Okay. Let's do $20.
All right.
In fact, I've got a feeling that one more of these and you're going to have it down pat.
Okay.
You agree?
Yeah. Then we can move
There's
on.
really only two rules, and then you have to check your solutions. What's the first step here?
Divide by 3.
Okay. Now what?
Now it's 2x minus 1 is greater than or equal to 7, or 2x plus 1.
No, never change what's inside.
Right. Minus 1 is less than or equal to negative 7.
There you go. And solve both of those. All right. Let's go to domain and range.
All right.
Determine whether each relation is a function. Number 12. Now, what's the hard way of doing this?
Not foiling it all, but adding them all together,
No,
I think.
no. The hard way would be to plot the points.
Okay.
There's 1 point, the first one, 1 comma minus 2. Another point is minus 2, 0.
Oh, just to see if they match up at all.
Just to see if it's going to pass the vertical line test when we're done. Okay, minus 1, 2 is right there. And 1 comma 3 is right there.
Right.
Does that pass the vertical line test?
Yeah.
No, it doesn't.
No, it doesn't. I'm sorry.
If I pass a vertical line right through there, remember it has to pass the vertical line test throughout the entire domain of the function.
Right.
And so visually we can see that it doesn't, but algebraically we can see that for the same value of x, we have two different values of y. That causes it to flunk the vertical line test. In other words, when x is 1, they're telling us y is minus 2, but they're also saying when x is 1, y is 3. Well, you can't have two different values of y for one value of x. That is not a function if you have that.
Okay.
Okay, so rather than graph the others, let's just look and see if we can find that. Let's look at 13.
13 looks like it would be 1, yes.
Looks like it would be a function because there's only 5 different values of x. So we can't even have the same value of x having two different values of y.
Right.
So we don't even need to look any further on that. How about this one? 14.
14 looks like it would be 1.
It would be a function because, again, we don't have same values of x anywhere. We got a 17, we got a 15 over 4, we got a 15, and we got a 17 over 4. Those are all different numbers. So for it not to be a function, you have to have the same value of x. In other words, in number 12, we had here was an x of 1, and over here was an x of 1.
Right.
That's what's going to cause it not to be a function. But 13 and 14 have 4 different values for x, so they're both functions. 15 has 4 different values for x. Got a minus 3, a minus 2, a 3 halves, and a 5.
Right.
Now, the fact that we have 2 different values for x and the same value for y, that doesn't hurt. Notice that if I plot this minus 3, here's minus 3 2/5. There's that point, minus 3 comma 2/5. And this point over here, 5 comma 2/5 is way over here.
Okay.
That's still a function. That passes the vertical line test. In other words, add a few more dots in front of there, and I've got a function like that. Passes the vertical line test. So you can have the same values of y for 2 different values of x. That does not flunk. What you can't have is the reverse. You can't have a point here and another point below it. Or you can't have something that loops on itself like that. That flunks the vertical line test right there.
Okay.
Okay. Use the vertical line test to determine whether each is a function. Is 16?
16 is yes.
17?
No.
18?
Yes.
19?
Yes.
20?
No.
21?
Yep.
Beautiful. Have you had one-to-one functions yet? No, you probably haven't.
No.
That doesn't mean anything to you?
Nope.
Okay.
No.
For each function, find this. These are really easy. If f of a is equal, what this means is this is a function of a, and this is what the function is. So what is f of minus 5?
Negative 10 plus 3. So.
What is f of minus 3?
Oh, negative 6 plus 3, so negative 3.
What is f of 1/2?
1 plus 3. So.
And what is f of 4?
F of 4, so 8 plus 3, so 11.
Okay, and the last one I'm going to add myself. What is f of x squared?
Of x squared. That would become 2a x squared. Or does the x squared... Okay, yeah.
What did we do in all these others? We took whatever was inside the parentheses and substituted it for a.
Right.
So even if it's a variable, you can do the same thing.
Okay.
Okay? So I know you know how to do all of these.
Yeah.
Let's go on to the next. Graphing lines. Find the slope of the line through each pair of points. Slope is what?
Slope is rise over run.
That's the most important thing to ever remember about slope. In number 12, what's the rise?
Number 12, the rise. Isn't it 9 plus 3?
It's the difference in the y values.
Okay. So it would be 6.
Okay, and the only thing that matters is you go in the same direction for the x values. In other words, you took 9 minus 3, so you have to go minus 3 minus 0.
Right.
Which is?
That would come to negative 2 if you rounded it off, wouldn't you?
Well, the denominator is minus 3, so the slope is minus 2.
Right, when you simplified it.
Yeah, simplifying is the word you want there, not rounding off. Rounding off would indicate that it was 6.1 over 3, and that rounds off to 2.
Right.
But 6 over 3 simplifies to 2. Okay. What's the slope of 14?
Negative 4 over, that would be negative 5.
What's minus 4 minus 7?
Minus 7. Oh, shoot, I looked at the 1. It'd be minus 11.
So the slope would be 4/11ths, positive.
Right.
And notice that it doesn't matter which way we go. Let's go the other way. In other words, let's start by 1 minus a minus 3. That'd be a positive 4. And what is 7 minus a minus 4? That's positive 11. So we get 4/11ths regardless of which way we go.
Okay.
In other words, you can go either way you want, just be consistent. Don't switch them up or you'll get the wrong sign on your slope.
Okay.
16, what's the slope on 16?
That would be negative 1 over negative 1.
So what's the slope?
1 over 1.
Just 1. What's the slope on 18?
On 18, 0 over 1.
Which is? What's the slope?
Wouldn't it be no slope?
It's a 0 slope.
Okay.
If the slope comes out to be 0, then it's 0.
Okay.
If the slope comes out to where you're dividing by 0, then it's an infinite slope, and that's a vertical line.
Okay.
Okay? This is a horizontal line. If you plot both of these points, you'll get a horizontal line. If you connect,
Okay.
well, if you had a vertical line and you had 2 points, it's going to be the x-coordinate that's the same. So you're going to have rise divided by run. The run's going to be 0. You're going to be dividing by 0. That's infinity. That's why that's an infinite slope. Okay, 51.
It'd be up 1 over 1, 2, 1/3. Up 1
Good.
over 3.
Is it positive or negative?
Positive.
Right. You know it's positive just by looking at that line.
Yeah, the way it's pointing.
Don't get your positive or negative from the direction you have to go when you go up 1 and over, because that can be very confusing, as we'll see with 53. Make sure you get the number, and then you look at the line to see whether it's positive or negative. So what's the slope on 52?
It runs 1, 2, 3, 2 over 2 to 3.
Positive or negative?
Positive.
Positive 2/3. It's not 2 to 3. We're not talking of a ratio. We're talking of a pure number. 2/3 is the slope on that line. What about 53?
53 is a negative, down 1, then over 1, 2, 3. A negative 1/3.
Look closely. Can you see my cursor?
Yeah.
What's the x value right there?
2.
Here's 2 over here. What's the x value there?
Oh, the x value would be 1.
What's the x value here?
5.
What's the difference between those?
4.
So that's the run. What's the y change when I go from this point to this point? How much does y change?
Just 1.
Okay. So the slope is 1/4, and you can look at it to know that it's negative.
Right.
Now the other way to get the negative out of it is I had to go down 1, which is a negative 1, and then I had to go to the right by 4, which is a positive 4. So I can get it algebraically, but you have to be very careful about that.
Okay.
Best way is to get the number and then look at the direction of the line to figure out whether that's positive or negative slope.
Okay.
What is this kind of slope here?
That's a negative slope.
What is this kind of slope here?
A positive slope.
Okay. 54. Find the slope and the intercepts of each line. I think you can just tell me these.
The slope is 2/3. The intercept is 4.
Okay. 55.
The slope is negative 1, and intercept is 1,000.
Okay. 56.
The slope is 0.8, and the
Hold on. What's the slope?
negative 0.8,
Okay.
and then the intercept is 0.4.
And the reason is that if I write that, in other words, they gave it to us like this, trying to fool us. Well, I need to switch that around. Well, if I switch it around, I can't throw away that negative sign.
Right.
And this has a plus in front of it to begin with, so it translates to that. Now I can see my slope is negative 0.8 and my y-intercept is 0.4.
Okay.
So always be careful of that. Number 58.
58, the slope would be 1, and the intercept would be negative 3.
Okay, I'm going to plot. X equals -3 is a vertical line that goes through the x value at -3. What's the slope on that vertical line?
0.
No, this is a 0 slope. And this is a slope of 1. This is a slope of 2, 3, 4, 5, 6. What's a vertical line slope?
6?
Infinity.
Infinity, okay.
Undefined is what they'll say in class.
Okay.
Undefined, because the rise is infinite and the run is 0. So if I do rise divided by run, I'm going to divide by 0. And whenever you divide by 0, you've got infinity, or undefined.
Okay.
Okay, how about 59? Y equals 0.
That would be a no slope.
No, that would be a 0 slope. There's the line y equals 0. It's a horizontal line that falls on top of the x-axis.
So what's the difference between a no slope and a 0 slope?
0 slope is a horizontal line. I don't know what no slope means. I guess no slope means undefined. Is that what they call it in your class, is no slope?
Yeah.
Because it's not really no slope. No slope would indicate 0 to me.
Okay.
If you tell me something, if we go skiing and you say you don't want to go on the bunny run because it doesn't have any slope to it, to me that means it's totally flat and you wouldn't be able to ski, right?
Okay.
So no slope is the same as 0 slope. Infinite slope is not the same as no slope at all. Infinite slope, I mean, watch what happens. There's a slope of 1. There's a slope of 2. There's a slope of 10. There's a slope of 100. Here's a slope of 1,000,000. You see what's happening?
Yeah, it's getting bigger.
As I get closer and closer to a vertical line, the slope gets infinitely large. So it's certainly not no slope, and that would be an improper word to use to describe it.
Okay.
Okay? It would be undefined or infinite, but not no slope. I don't like that. No slope to me means 0 slope.
Okay.
No meaning 0 to me. All right. These are pretty good. This is some good algebra review for you. Although, yeah, this is really taught more in algebra than it is in geometry. So 37, what's the slope of that line? Y equals 7.
It'd be 0 slope.
Okay. Okay, so if we want, let me show you how to do a few of these, and then I think you'll get the technique. These are a higher degree of difficulty for sure. So they want a line that goes through this point and is parallel to this line. Well, conceptually, if I graph this line here, that's got a y-intercept of 1 and a -3 slope. So it's got to go through this point. It's got to have a steeper than normal slope, and it's got to be -3.
Okay.
So that's that line there. Well, a line that's parallel to that, what is that going to mean?
It has the same slope.
Aha. So the line we're looking for in this format is y equal -3x plus b, right?
Right.
So this line is going to be parallel to the line that they have given us. Well, I don't have b. How do I solve for b?
Get it by itself.
Well, I know that this new line, the new line that I'm going to come up with, goes through this point -2, 1.
Okay.
That allows me to solve for b. How do I solve for b? If I know that the point minus 2 comma 1 has to be in that curve, I can plug in minus 2 for x, I can plug in 1 for y, and then the only thing left to solve for is b. So I'm going to let 1 equal y. You see y?
Yeah.
Okay, equals minus 3 times minus 2, the x value, plus b. Well, this is equal to 6. Move to the other side, it's equal to minus 5, so b is equal to minus 5. Okay, so if b is equal to minus 5, I just need to plug it into there, and there's my new equation.
Okay.
Okay, now let's plot that equation just to make sure that we've got what they want. Well, if I'm plotting this equation, the y-intercept is at minus 5, the slope is still minus 3, so it's going to be perfectly parallel to that other line. There's your parallel line, and it goes through the point minus 2 comma 1.
Okay.
Okay? Let's do 39.
39. All right.
The line that they're giving us, the equation they give us, is this. Only this time they want a line that is perpendicular to this line and goes through this point.
So wouldn't it be like the reciprocal of that? So it'd be
The negative reciprocal. So the slope of the perpendicular line is what?
Wouldn't it be 2/5 x plus 4?
It's the reciprocal of m.
5.
Negative reciprocal. 5/2. The negative reciprocal.
Okay.
Okay? So now I know the slope of my new line, right? So here's the standard equation, y equal mx plus b. Only thing I know about this new line is the slope. So I can say this. I also know a point that it goes through. It goes through the point minus 3 comma minus 1. So what do I do with that information?
Plug it in.
Okay? So tell me what to write.
So with the for y is -1. So
Okay.
-1 equals 5/2 times 3.
Negative 3.
Oh, sorry, I didn't see the negative sign there. So -3, and then yeah, equals b. So that's 15/2. Negative 15/2. Sorry.
Okay.
And then get that all on one side.
Okay. So it's -1 plus 15/2.
Right.
-1 is -2/2. So adding those two things gives me 13/2 equals b. So what's the equation of the line that we want?
The equation of the line. That is.
Yeah, that's what they want, is the equation of that line. In other words, an equation of a line describes everything there is to know about that line. Its exact positioning on the coordinate xy plane.
Okay, so we gotta add, it looks like
Y equals what?
y would equal just, b would equal 15/2.
13/2.
Well, wouldn't you add the 2 and 2/2?
When I have a minus 2/2 plus 15/2, I result in 13/2.
I thought it was a plus. Plus 2/2.
It's minus 1 plus 15 halves.
Oh, okay, I see.
Okay, so b is 13 halves. So what is the equation of our line?
13,
It's got to be y equals
y
mx
equals,
plus b.
right, y equals 2/5
No,
x.
no. 2/5 was the slope of the line they gave us, not the line we're coming up with.
Okay, so it would be 5/2 x plus 13 halves.
There you go. Same exact process each time. Now, there is another way to do this using what's called the point slope format. Have you had that?
Yeah, she told us not to use that.
Okay. It's the more complicated one. Actually, it's not. It's the simpler one, but you have to know what the format is. And most people are very familiar with y equal mx plus b, and they're not so familiar with the other format.
Yeah, she just asked us not to use that one.
Okay. So let's do 40. So we have a horizontal line that goes through minus 7, comma 10.
Okay.
First of all, what's the equation of horizontal lines look like?
The equation that would look like, I'm not sure.
There's a horizontal line. What's the equation of that line?
Y equals 0?
Approximately 3, the way I drew it.
Oh, because it's going through the y-intercept, and then x equals 0.
Yes. Well, more importantly, x doesn't equal 0. Y equals mx plus b. M is on a horizontal line, slope is 0. So if I substitute 0 for m, the x disappears and I get y equals the y-intercept. Well, in this case, the y-intercept is 10. Always. In other words, they say that it goes through the point minus 7, 10. But it's a horizontal line. So this has to be 10. So the equation of that horizontal line is y equals 10.
Okay.
Okay? 41. Similar, only it's a vertical line. What is the format, the typical format of vertical lines?
Then it would be y equals 0. The y-intercept equals 0.
No, forget about intercepts for a moment and think about horizontal and vertical lines. Horizontal lines have the format y equals a number. Vertical lines have the format x equals a number.
Okay.
Okay? So we just need x. What number is it?
It'd be 1, wouldn't it?
Yes, x equal 1 is the vertical line that goes right down through the x value of 1.
Okay.
Now, they're saying that the point 1 comma minus 2/7 is on there, but we don't really care about this. If it's a vertical line, it's x equal 1.
Okay.
Okay. All right. Why don't we... How far did we get?
We
Was
got
that
through
the...
all of them.
Is that the last one? Yeah, writing equations of lines?
Yeah.
Okay. Well, that was a good session.
Yeah.
I think we probably needed to be doing more algebra and less geometry, just because it looks like you need refreshing on your algebra a little bit.
Yeah, it's tiny bit.
Okay. Sounds good. You still in school next week?
Next week, yes, I will be.
So
We get out to the...
you still need a session on Wednesday?
Wednesday the 22nd? Yes, I
Yeah.
will.
And how about the session on Monday the 20th?
I think so, because we have a big review packet, and it'll probably just be easier to try and knock it out within those days.
Sounds good. I'll talk to you on Monday, Ryan.
Alrighty, sounds good. Thank you very much.
Bye-bye.